Hey people, what's going on? This is a video which will take a slightly more in detailed look at this robot that I've created. Um, it's not really a robot. It's more of a radio controlled car, uh, just with one sensor on it, which is this sonar sensor. And that's the only real intelligence built into the device. Apart from that, it's all controlled via this controller. Now, I've implemented both forward direction and backwards uh, on the controller, so that so that this can go forwards and backwards. Okay, so let's start from the motor, and here it is. Um, so that's the motor. Now, I've included two separate sets of batteries to run the motor completely on a separate power source to the microcontroller. Now, the microcontroller is run via this battery on the top layer you see, um, which gives 3 volts to the microcontroller. And the way it's been isolated is using this optocoupler chip. So this chip, it receives signals from the microcontroller, and it then switches on an LED inside the chip, which then switches on a transistor um, within the chip. Now the LED and the transistor are completely independent from one another, unconnected, and the LED uh, is completely electrically isolated from the transistor. So the LED can be connected to one power source, which is the power source for the microcontroller, and the transistor can be connected to the other power source, which is the power source to the motor. So the motor is being powered by a 6-volt power supply, and here it is. Okay, and as you can see, if you look closely enough, I've actually simply blue tacked the motor and the wheels onto this board. I couldn't find anything, so just stuck it with blue tack, and it actually works quite well. Okay, so once we've got the signal from the microcontroller, then it switches on a transistor. Now the transistor, again, we can just use as a logical device, and when the transistor goes on and off, it sends signals to this chip here. Now this is critical. This chip is a H-bridge chip, and H-bridges are used to control motors. So logic ones and zeros are sent to this chip. This chip then switches on power transistors within it to supply power to the motor. And all of this is electrically isolated from the microcontroller, so the microcontroller is really unaffected by what's going on here, and any disturbances in the power flow or any spikes in voltages due to back EMF do not affect the microcontroller, because that's much more sensitive than all the passive, mostly passive equipment that you have here, or power semiconductors which can handle such voltage spikes. Okay, so that's the motor, and that's the chip that really just delivers power to the motor, um, and depending on the signals from the controller. Okay, so on the microcontroller side, what we have is a chip here, which is the radio frequency receiver, and it simply receives information from the excuse me, from the control, from the remote control. Okay, and then that information is fed into the microcontroller. It gets decoded, um, and depending on what the information is. It's the motor is either switched on uh, in forward direction, um, remains off, or switches on in backward direction. Okay, so right at the front here, what we have is the sonar sensor, this little boy, and that's the only sensor that I've included so far on the on the on the on the board, um, and that's the only intelligence that this system really has. And what that sonar sensor does is it detects the distance from itself to the nearest object in front of it. So what I've programmed it to do is simply when it measures the distance uh, to be less than 10 to 15 centimeters. If the distance is less than that, approximately, then the motor just switches off. It sends a signal to the motor not to go any further ahead. It can go backwards, but it can't go forwards, and that's pretty much it, really. Um, and uh, and on the controller side, it's a very simple circuit. I've just included just one microcontroller, and which depending on the inputs from the buttons, um, outputs a certain um, value or certain code to the um, transmitter, to the radio frequency transmitter, which then sends it via the antenna, blah blah, and this antenna receives it, and the rest gets processed. And okay, that's all. Thanks.